Hi, welcome back to the channel. In this lesson, we'll take a worked example on electric field strength and intensity. We'll see the electric field strength itself, we'll see resolution of forces, and also we'll see how to deal with the Cartesian geometry. That said, let's get into class. Example says 3 point charges in air are located as follows: at 5 times 10 raised to power minus 8 coulomb at 0 meters. Now let's start with the Cartesian coordinate. Now here's my y-axis and here's my x-axis. The first point charge of 5 times 10 raised to power minus 8 is at 0. This is the point of 0. So where the y-axis crosses the x-axis. This is my 5 times 10 raised to power minus 8 coulombs. The second charge, 4, is at 3 on the x-axis. Let's take it this way. This is 1, 2, and 3. I'll take this point as 3. Then this is where I have my 4 times 10 raised to power minus 8 coulombs. And this point is here. And the last one of the charges, that is a minus 6. Now let's take note that this 5 is a positive charge and this 4 also is a positive charge. Now we are to take the last one is at 0 on the x-axis and 4 on the y-axis. Let's mark it. This is 1, 2, 3, 4. So this is where I have it. This is 4. And the charge itself is minus 6 times 10 raised to power minus 8 coulomb. Now, if you look at it now, I have this at 4. I have here is 0. And here is 3. They actually form like a triangle. You look at it like a triangle. Now, we have to calculate the field intensity at 3 and 4. It is 3 on the x-axis. Here is 3. And we'll trace it to 4 and 4 on the x-axis. That forms a perfect rectangle. So from here to this point is 3, while from here to this point is 4. So here's now we'll place a positive charge here to calculate the electric field intensity. Now, in case you missed our introductory lesson for electric field intensity, we'll place a link here for you to access it, and we'll also place a link to it in the description. Now, the first thing I want us to do is to look at the direction of force, or rather the direction of the electric field. Remember, the direction of the electric field is the same thing as the direction of the force. Now, going to the first charge, which is 5 here, which is a positive charge, we've placed a positive charge here to calculate the electric field intensity. There will be force of repulsion, which will go in this direction. Now, going to the second charge, which is a positive charge too, there should also be a force of repulsion, which will push it into this direction. Then, owing to this negative charge, there should be a force of attraction between them, which will push it to this direction. Now, we can now begin to calculate each of the force. Let's tag this F1, I'll tag this F2, and I'll tag this F3. Now, remember E rather, it should be E, not F rather, because we're talking of electric field intensity, E. Now, remember that E is the same thing as Q times K over R squared, which is the same thing as Q times 9 times 10 raised to power 9 over R squared. So for each of them, for my F1, we'll be saying that my Q for F1 is 5. That's the 5 times 10 raised to power minus 8 times 9 times 10 raised to power 9 over R squared. R is the distance between them. Okay, here we need to calculate this distance because this is the distance R. Let's tag this as our R1. Now, for my R1 here, the distance between the 5 and this and the positive electron, can tag my R here to be the same thing as we'll use Pythagoras theorem. That will be 4 raised to power 3 plus the square root of 4 raised to power 3 plus 3 raised to power 3. Because from here to this point here is 3, and from here to this point here is 4. So that R now will be the same thing as the square root of 16 plus 9, which is the square root of 25, which is the same thing as 5. So my R1 here is 5. So I can easily place 5 squared here. That's 5 times 5. 5 here is 1, 5 here is 1. So that F1 will be the same thing as 9 over 5 times 10 raised to power minus 8 and 1. That is raised to power 1. That's the same thing as 1.8 times 10. Not F1, sorry, it's E. I'm making that same mistake again. That is E now, that is electric field intensity, will be in newtons per coulomb, which is the same thing as 18 newtons per coulomb. Now the next thing is to look for F2, or E2 rather. To look for E2, we'll still be talking of Q K over R squared. And in this situation, my Q for E2, let's get back to the diagram. My E2 is 4 times 10 raised to power minus 8. That's my Q. Now, here is a 4 times 10 raised to power minus 8. I have that charge here. Now, the distance between this charge here and this particular electron is 4. So, my R here will be 4, and my Q is 4 times 10 raised to power minus 8. That's 4 times 10 raised to power minus 8 times 9 times 10 raised to power 9 over R squared. That's 4 times 4. 4 is already given in meters. 4 cancels 4 here, so that I will have 9 over 4 times 10, which is the same thing as 20, same thing as 2.25 times 10. That's the same thing as 22.5 newtons per coulomb. Now let's take the last E. We'll calculate the last E, which will be the same thing as Q times K over R squared. Now that will be, let's get back to the diagram again. My Q in this case is 6 times 10 to the power minus 8, which is what you have here. But the distance between them, between here and this proton, or the positive charge rather, is the same thing as 3 meters. That's 3 meters. So that will be 6. That will be 6 times 10 raised to the power minus 8 times 9 times 10 raised to the power 9 over 3 times 3. 3 here is 1. 3 in 9 is 3. 3 here is 1. 3 here is 1. So I'll have 6 times 10. That's the same thing as 60 Newton per coulomb. Now we have all the electric field intensities. We have our E1, E2, and E3. Now the next thing I want us to do is I want to redraw this, or because now we have the E2, we have the E1, the E2, and obviously the E3. Now the next thing I want us to do, for clarity's sake, I want us to redraw this. But before we redraw it, I want us to resolve, we have to resolve each of the electric field to the X and the Y axis to make resolution easy. Now, here is our electric field. Here's our E1, here's our E2, and here is our E3. Now for my E1, okay, let's pick E1 first. For my E1 is 18 Newton per coulomb. Here is 18. Now at what angle is 18 to the x-axis? I want to do this so that I can resolve my E1 to both the y-axis, and let's call this EY, and let's call this EX. Both the y-axis and the x-axis. Now, if you missed our lesson where we explain resolution of forces, we'll place a link to that lesson in the description below. Now, so that my E2 Let me see the value of my E2. My E2 is 22.5 and my E3 is 60. E3 here, this is 60 Newton per coulomb, and this is 22.5. Now with this, let's get back to the diagram so that we can pick our angle. Now to pick this angle, if you look at this carefully, now the angle we have here, if this place is theta, obviously what we'll have here to meet my diagram also will be theta. So that to resolve this angle, I can easily come up with my tan of theta and theta to be the same thing as 4/3. So that arctan of theta will be or theta will now be the arctan of 4/3 is the same thing as 1.33. So that theta invariably will be the same thing as, for my calculator, theta invariably will be the same thing as 53.061. So the angle in question is 53.061. That is the angle at this edge is 53 point. This is theta. That's the same thing as 53.061. Now my EX the same thing as 18. That's E1 cos 53.061. Now if you put this in my calculator, that will be the same thing as 10.817. And my EY will be the same thing as 18 sine 53.061. So that my EY invariably is the same thing as 14.38. Now, let's resolve this diagram to now begin to look like this. Where we have an EY, a final EY, and my final EX. So let's call this E1 of XE. My final EY will be the same thing since EY of 1 here is in the same direction with E2 will be the same thing as E2 plus E1Y, which will be equals to 22.5 plus 14.38. That's the same thing as 36.88 Newton. And EX also should be the same thing because my E3 is in different directions, will be the same thing as 60 minus 10.817, which is the same thing as 49.13. 49.13. Now, so that EX here, this is 49.13 and EY is 36.88. Now, to finally get the value of the resultant, my resultant should be this way. Now, how did I pick that? If you pick this, you look at my EY comes this way, my EX comes this way. So I have my resultant, permit my diagram. This is my ER. So that's my ER. Now, I have this to be 36.8. Here is 43.1. So that my resultant R now become the square root of 49.13 squared plus 36.88 squared. R now will be given as 61.5 Newton per coulomb. Now we can modify it with respect to its angle. With respect to its angle, we can pick the cos of theta. Here is the cos of theta. Here's theta. We've gotten R here to be 61.5. So the cos of theta from there, which is adjacent over opposite, or sorry, adjacent over hypotenuse, that will be 49.13 over 61.5. So that theta invariably is the same thing as 36.9 degrees. So that the electric field, we have an electric field of 61.5 Newton per coulomb acting at 36.9 degrees. Now with this, I hope you understand how to work the electric field strength and intensity. In our next lesson, we'll take another question to help us still illustrate it better. Thank you for staying with us and see you in our next class.